In this module, we shift from building the wallet onboarding solution to defending it. You'll see how threat modeling, Azure security controls, and privacy by design work together to protect wallet interactions, verifier services, KYC evidence, user consent, and regulated identity data. You've already done the hard design work, understanding EDS and wallets, mapping KYC and GDPR into requirements, shaping user journeys, and defining architecture, protocols, and Azure deployment. Now we turn those design decisions into concrete threat models, security controls, and privacy by design measures that harden your production environment. Our goal is a trusted wallet-based KYC process that balances four forces. Security wants the entire onboarding flow locked down end-to-end. Privacy pushes for minimal purpose-bound data, used only with clear consent. Compliance demands that every control can be traced back to a regulatory requirement. Architecture turns all of that into practical design choices across wallets, APIs, verifiers, and evidence stores, so users stay protected while audits remain possible. Threat modeling here means asking, at every step of onboarding, what could go wrong and who could abuse this? We start by protecting the real crown jewels: identity attributes, credentials, consent records, logs, and keys. Then we examine each trust boundary between the device, wallet, verifiers, cloud services, and KYC systems, and apply stride thinking. Finally, we prioritize the controls that most affect assurance, compliance, privacy, and the overall integrity of onboarding. In this flow, the risk isn't just a hacked wallet, it's who you're really talking to. Attackers can ship a fake wallet app or silently intercept a handoff, so the user thinks they're approving a normal request while data flows to the attacker. On the other side, a weakly authenticated relying party can pretend to be a bank or hospital. To counter this, robust signatures, endpoint validation, and clear user-facing cues must confirm who's asking, why they're asking, and which attributes are being requested. Replay, man-in-the-middle, and token abuse all exploit weak points in the same flow. If a presentation can be reused, an attacker can simply replay it in a different session or against a different relying party. If messages can be intercepted or altered, they can swap redirect URIs, inject claims, or downgrade security. Defenses hinge on strict nonce and state checks, strong TLS, signed and audience-bound artifacts, and aggressive expiry and revocation of tokens. Consent manipulation happens when users are nudged into agreeing to more than they understand or genuinely need to share. That includes vague purposes, pre-checked boxes, or broad data grabs justified as consent. A well-designed onboarding asks only for necessary attributes, clearly explains why they're needed, limits tracking, and keeps verifiable records of exactly what the user approved and when. Wallet-based KYC only works if every trust layer is solid. First, you need a reliable trust registry. If issuer metadata is stale, issuers are misclassified, or certificates aren't validated, you're basing decisions on fiction. Next, every credential must be checked for revocation, suspension, and expiry at the moment of use. Finally, you maintain tight, privacy-preserving logs so you can later prove what evidence you saw and why you made a given decision. Think of securing an OIDC4VP flow as a chain of checks. First, you protect the request itself using signed authorization requests or request objects. Next, you bind the response to the session by validating nonce, state, redirect URI, and client metadata. Then you validate tokens, issuer, audience, and expiration. After that, you verify signatures on presentations and credentials. And finally, you enforce trust and status, rejecting anything replayed, malformed, untrusted, or off-spec. Now we move behind the wallet to protect APIs, keys, and service-to-service calls. Services authenticate to each other with managed identities, not hard-coded secrets, and their keys and certificates live in Key Vault with tight access policies. Every component only gets the minimum permissions it needs, enforced through RBAC and environment isolation. APIs are fronted with OAuth 2.0, gateway enforcement, MTLS where needed, plus rate limiting and strict input validation. Treat keys and secrets as living assets that move through a lifecycle. They're created, used, rotated, and eventually decommissioned, and each phase needs clear rules. You generate them in a controlled way and store them centrally in Key Vault or HSM. You define rotation for signing keys, TLS certificates, and API credentials, and continuously monitor usage and expiry while separating production from non-production. Finally, you're ready to revoke and retire anything suspicious or no longer needed. Privacy by design here means you never treat wallet data as a free buffet. You start from all the attributes the credential could reveal, then narrow to only what's needed for KYC, perhaps 18 or over, a legal name, an address, and an assurance level. Selective disclosure and derived attributes avoid exposing full documents. Pseudonymization breaks direct identity links, and separating evidence, decisions, logs, and analytics prevents everything from being tied back to one person unnecessarily. Consent evidence isn't just user-clicked agree. You need a clear record of who asked, what was asked for, why, what the user actually did, when it happened, and which wording they saw. Then you classify the resulting data: regulatory evidence, operational logs, fraud signals, and short-lived protocol traces. For each category, you define retention, deletion, archival, and legal hold rules, and strictly limit who can see what, so KYC stays defensible without hoarding data. Each Azure security service implements specific controls, not just more security. Defender for cloud maps to posture management controls. It checks configurations and drives hardening. Sentinel maps to detection and response. CM, SOAR, investigation, and automation. Azure Monitor and Log Analytics map to logging and monitoring controls. Azure Policy, Key Vault, Private Networking, and Managed Identities map to governance, secrets, isolation, and identity controls that enforce your security and privacy architecture. Security and privacy architecture is what turns a clever wallet-based KYC design into something you can safely run in production. You've seen how to map threats to concrete security and privacy controls. Next, we'll focus on operations, observability, incident response, compliance evidence, and overall production readiness.